Hello everyone, and thanks the organizers for inviting me for this very nice meeting. And I hope you will learn a lot of new knowledge and have some inspiration for the future work. Okay, so let me allow to start with the presentation. And I will try to tell you something about or general introduction to climate change as it relates to food security or even the security in general. So this is just a quote from the current Pope, who is very active in the environmental policy, and he tries to educate people or Christian community to environmental problems, and he says that God always forgives, people can sometimes forgive, but nature never forgives. That means that if we break the laws of nature, she will not discuss with us if we could it differently. She simply does the things according to her laws. So this is the graph of the global population during the last 10,000 years. As you are probably aware, the population is growing very rapidly, even if the growth is a little bit slower than it was in the past. So currently there is 7.5 billion people. And this is the prognosis up until 2100. And you can understand that this is not sustainable, and it will create the growing demand for energy, for food, and for everything. We are already at the time when the number of children born is peaking, so that means that population will be growing older, which creates its own problems. So there will be not so many young people to support aging population. And even if there is no climate change, of course, growing population is problem by itself. So we need to grow everything. And according to latest data, we have to increase the food production by 60% by 2050. The latest report by UN says that every year we need to create 4 million hectares of new land for agricultural production, which again is not sustainable. So as the number of people is growing, so is the fossil fuel consumption. Here you can see the graph of fossil fuel burning, which is coal, oil, and natural gas mainly. And you can see it's still growing. In the last few years, it's maybe slowing down, so we will see how it goes into the future. But again, still the fossil fuel burning is growing, and this is something that Paris Agreement is aiming to change. But we will see. Of course, as we burn fossil fuels, the CO2 concentration goes up. So this is the graph of CO2 for the last 800,000 years. But from the other data, we know that currently the CO2 is as high as it was last time, something like 15 to 20 million years. So we are going, in terms of climate change, back to the past. So, and in the past, the climate was much warmer than today. So we are already about 400 ppm, and the CO2 is increasing very fast. The rate of the growth is very important. We know that the CO2 is growing at least 10 times faster than any time in the last 66 million years. So the faster we change the climate, the bigger problems it creates for not only for humans, but also for other life and ecosystems on the planet. So the rate of the change is problem. Okay. Yeah. So we have not only CO2, which is the most important greenhouse gas, we have also methane, and the methane is also growing very fast. You can see that in the last few years, the methane concentration is growing faster, and there is some fear that methane is creating an important feedback. It's like 25 times stronger greenhouse gas than CO2. And there is some latest research that shows that methane concentration are growing, especially in the Arctic. And as the Arctic ice is melting, it can support the escape of methane from the from below the ice and from the soils, and it can be an important positive feedback. It means that it will speed up the warming. This is just the graph to show you, because there are some people still doubting that if we are causing the climate change, and they are saying that the sun activity might be the main factor. So this is just to show you that really there is no other factor that would explain climate change. The scientists know that the main reason why the climate is warming is human activity. So the sun activity is not increasing over time. So this is the global temperature from the instrumental measurements for the last 125 years or so. And you see that the global warming is very much continuing. There were again some people saying that there is some slowdown, so there is no warming, but so simply so in the last 100 years, the global temperature increased by more than 1 degree of global average. So this is the longer term perspective. You can here see the temperature over the last 20,000 years, and you can see here this 1 degree that has already warmed up, and you can see that currently we are higher than during the whole Holocene. This is the so-called Holocene era, and currently the temperatures are probably as high as it was last time 120,000 years ago, and if we go a little bit higher, the temperature will be as high as 2 million years ago last time. So this is just to show you probably the temperature that is suitable for our global civilization. We need stable global temperatures to sustain agriculture and to have a stable weather patterns and so on. So this is just to show you that we really don't have much time to reduce carbon emissions to keep the climate stable. Okay, this is what I told. So it means we don't have to grow too much with the temperature, and we are going back to the past, like 2 million years ago, where the temperature was as high as today. Yeah, so this is the same. I will just skip it, just to continue. So there is the correlation between CO2 and temperature, and once we increase CO2, we increase the temperature. Another important thing that is related to food security is also the decline of pH in the oceans. So this is just the graph showing the evolution of pH in the last 60 million years, and this is the prognosis for the future. And as we change the ocean chemistry, we also impact the food productivity of the oceans, which is, as you know, is very important for people as well. Okay. So just let's go to the impacts of climate change, some introduction again. So as I said, as we change the oceans, we kill the coral reefs. Maybe you have catched the information that as of now, more than 20% of Great Barrier Reef was killed by the heat wave in the last 4 years. And again, coral reefs are something like tropical forests on the continent. So once we destroy coral reefs, it destroys a lot of productivity from the oceans. So here you can see the decline of Arctic ice. As I already mentioned, Arctic ice is important because it can lead to increase of methane emissions, and it will speed up the global warming. The Arctic is already warming 2-3 times faster than the global average, so it's the region where the warming is fastest. And here you can see the comparison between climate models and observations, and you can see that climate models are underestimating the rate of sea ice decline in the Arctic, so probably the changes will be much faster than we currently predict. Why is it important? So here is the Arctic, and as the Arctic is warming, it is affecting the weather patterns. Here what you can see is so-called jet stream and so-called Rossby waves, and these are defining the weather patterns in our latitudes, be it Northern America or Europe or Asia. And there is some indication that as the Arctic melts, it will lead to more extreme weather. It means more heat waves, more floods, more extreme precipitation, and so on. So that's why Arctic ice is very important for us. And it will, of course, impact the food production. This is the decline of land glaciers. Land glaciers are very important for many people, and they are a source of water, be it for use for people or for use in agriculture. And there is estimation that once the land glaciers are depleted, they will endanger about 1 billion people on the planet. Sea level rise, as you probably know, as it gets warmer, the sea level is rising, and here is just the graph over the last 2,500 years, and these are the measurements, so you can see that the rate of sea level rise is fastest in this last, at least in this period, and it leads to the flooding, not only cities, but also, for instance, in Bangladesh, the rice farmers have problem with sea level rise and so on. Drought is very important for food production. So here you can see the graph of drought. So this is the Earth. It's without people. It means if there is no climate change. And on the y-axis you have the percentage of continents that is under drought. This is the drought index that takes into account precipitation and soil moisture and so on. And this is the real situation with people. So there is already increasing drought globally because of climate change. And this is the same just prediction for 2100. So this is no climate change, and this is the trend that will be in the future if there is increasing greenhouse gases and increasing warming temperature. So the warmer is, the more drought we will see in the future. On the other hand, we have precipitation. So as we get more drought, maybe paradoxically for some, but it's related to more heat in the atmosphere, we get also more extreme precipitation, so more floods, leading to a lot of damage. So this is the trend in extreme precipitation globally. It's global average, and this is what would be expected without climate change. So we already are observing more extreme precipitation than we should be observing without climate change. Okay, the same for extreme weather events. I will just make it faster. So at the beginning of century, on average, we had like 82 natural disasters for the 10-year average. And going to the present, we have more like 4,000 natural disasters, and most of the increase is in the hydrological group. So we have increasing number of floods. So okay, climate change and food security. This is just a quote from American Climate Change Program, Global Food Security Report from last year, and it says that climate change is very likely to disrupt the food availability exactly because of changing weather, so more extreme temperature, heat waves, and more extreme precipitation. This is just a prognosis, the change in the yields for different crops, like maize, rice, and so on, and how they will change with increasing global temperature. So again, the more warming, the higher likely decline in the yields. So this is the global average. So somewhere there might be gains, but the more warming you get, the less food you are able to produce. Again, this is just showing the number of farms in the Africa and Asia. So this is not for the whole globe, just for parts of the world. And you can see that more than 50% of farms will be vulnerable to climate losses. There can be some gains. And these are just two scenarios. It is for the middle of the century. So there can be some adaptation in the future. If we really adapt to the changes, we can mitigate some negative impacts, but not all of them. So this is just a recent publication from journal Nature, and it says that the current warming already will reduce the yields if we don't adapt immediately, which means that we already have to adapt in order to avoid really negative impacts. And they looked at Africa, where the impacts can be really the worst. And as you understand that Africa is a poor country, so they really don't have that resources to adapt, as for instance, I don't know, Europe or other countries which have more money to adapt to the changes. So as the climate is warming, so is the nature is reacting, And one of the problems with food production will be the spread of the food pests and spreading of diseases and various pathogens. So again, this is the recent paper showing that as we are warming, that there is migration of different, let's say, small animals that we don't like, and they are creating our food production capacity. So this study found out that on average, there is the movement of microorganisms like up to 3 kilometers per year to the cooler area. So on the northern hemisphere, they migrate to the north. On the southern, they migrate to the south. So they create a challenge for the algae culture and for farmers to adapt to these changes. Yeah. So again, this is just the risk or the report from last year that is saying that once we had like in 1 year or in 100 years we had the chance that 1 year out of 100 we will have a food shock. But now, as we, number of people is increasing, and we have other factors like climate change, we have like tripled the risk of food shock in the future. So we really need to take it into account and make some, adaptation measures to limit these negative outcomes. This is just an example of how the drought has already impacted some countries. So this is the study that has shown that the drought that was leading up to civil war in Syria was preceding this conflict. So a lot of people needed to migrate from farming areas because they lost the income. They cannot grow food because there was a biggest drought in something like 900 years. So they migrated. It was like 1.5 million people had to migrate. It was in Syria, but as well as in Iraq. And together with other problems, it led to the civil conflict that led to other knock-on effects like migration and so on. So the drought is already having negative impacts on many people. So yeah, this is just the picture from Syria. I think I don't need to speak about it too much. You know that it's a very serious situation, and it will probably spread to other countries as well in the future as the climate is warming. Okay, so this is the last slide, just to show you. So Paris Agreement said that we try to limit global warming, not more than 2 degrees, and ideally to 1.5 degrees Celsius compared to the pre-industrial temperature. In order to do that, we have no more than 5 years of current global temperature of CO2 to not cross this warming with some probability, but it's not that important. So it's not really probable that in 5 years we stop all the industrial production, no lights, no cars, no aircrafts, and so on. So it's really not possible to achieve 1.5 degrees, and it's an important limit for many reasons I don't have time to explain. But even the 2 degrees, which Paris Agreement was aiming as the upper limit, we have like maybe 10 or 15 years, but not more. So in 10 or 15 years, there can be no cars, no ships, at least not that would be powered by fossil fuels. So we need alternative energies. So you can just, do the calculation for yourself and think if that's possible. And that's all. So thank you for your attention.